Okay, hello to everybody. We are going to go on this webinar on forestry and forest biodiversity. We have kept now 3 lectures, and now is the last, I hope also not least, and 4th part. And this all belongs to Kolarctic CBC project on forestry, and it's ruled by in Finnish Association of for Nature Conservation Lapland in Finland, and in Sweden it is ruled by Skogsstyrelsen Norrbotten, and in Russia, in northwest Russia, it is led by WWF of Arkangel area. And on program we have today first Hillevi Eriksson from Sweden, and she's title is Some Ideas on Forest Biodiversity Protection in a Changing Climate in Sweden. And after Hillevi, we have a comment from Raisa Mäkipää from Natural Research Institute of Finland. And the second lecture we will have Raisa's climate change mitigation potential of land use sector and management of peatland forests, and it is started after 1 hour. But first we will have Hillevi Eriksson. But in this case I tell you something about how we are going on. Hillevi's lecture is some about half an hour, and that after is about 5 to 8 minutes Raisa's comment and then re-comments. After that is open discussion, and then you can, all the attendees can make questions, and do this please do chat, and we can choose there if there are really many. Sorry, we can't maybe read them all, but let's hope we can discuss enough already. And then first, Hillevi, please tell you who you are and start your lecture, please.
Yes, I am, as you can see, I am a climate and bioenergy specialist at the Swedish Forest Agency, Skogsstyrelsen. And so I'm not a biodiversity specialist, but I've been involved in the work on biodiversity. We have a Swedish environmental goal on forests biodiversity. And we have an extensive evaluation once every 4th year on that, and I participated in that work. So it's merely experiences from that work I will be talking about, and also I will focus a little bit on in the end about a certain activity which connects to the second speaker of Raisa Mäkipää's talk on re-wetting of wetlands, because we are working on that right now.
Good. We look forward, and I put this away now.
So now I share my screen, I hope.
Yes, you are now. You have divided your screen.
Yes, and here is the presentation. So I will give you some ideas of how we are thinking about what the changing climate means for forest biodiversity protection, which of course in itself is a very big subject. I just wanted to take this as one picture of the background. The present carbon dioxide emissions, or not the present, but the development over the last decades, and you can see the development here. I guess many of you are already familiar with this picture, but it is a background to illustrate that we need to not only focus very strongly on how we look at the mitigation work within our countries, but also have a global outlook and see that we have to work together with other countries in formulating what needs to be done. And as you can see, the rest of the world, if you take away India, EU, USA, and China, the rest of the world has climbed up from a quite low position to a very high position when it comes to emissions. And also we need to stop and start to decrease the emissions. And this is just a picture to illustrate the challenge that we have in front of us, that we need to change the energy system and also how we use material in society, what materials we use for building houses, and that also would be a very good thing to reduce the number of cows and other grazing or what do you say, methane emitting animals in the world. So this is what I often talk about, these things, but now I will talk about biodiversity a little bit. And there has been, of course, many large-scale reviews on the effects, what is happening. And two examples of such large-scale reviews are here, that one then for 800 species, mainly arthropods, the average migration of distribution areas northwards has been 1.7 kilometers per year, the average migration. That is one big review study. And another one which focused on butterflies, birds, and alpine plants showed a migration rate of 0.6 kilometers per year. These rates have probably not slowed off. They have probably rather increased in pace over the last decade. And the expected, if we look forward, is that a large percentages of the species we have in the world, up to 50% of bird species and 40% of amphibian and reptile species, are threatened already at a climate change of 2 degrees, the RCP 4.5. And it's easier, of course, for mobile and easily spread species. They can follow climate unless they are dependent on other species that lag behind. Typically, plant species take longer time, and trees, as you know, take long time to grow old. So if all those species that are dependent on old trees that is not yet there will have problems. So it is It is a great problem, as you know, and we already have the basic problem of the expanding human activities on taking more and more land into changing natural ecosystems into managed ones, which is the basic problem. So in what we have seen in Sweden, the most obvious example of change is that the migrating birds arrive earlier. I'm positive you have similar experiences in Finland, and it's the Swedish bird monitoring body that has shown this. So that is one example. I think there are many more examples to see when looking at literature, research literature. I know you have examples of butterflies in Finland. I have come across such results. And expected effects is this general migration northwards for many species because of the climate that they are adapted to is moving northwards, and the competition increases from south. So the more and more species that are not adapted to the very strong winter climate can survive to a higher extent. And then also here then we will have problems for species that are dependent on rare biotopes. They will have problems to maybe find enough. It will be too far between the sites, especially for the species that are not mobile and easily spread then. And also the species that are dependent on old broadleaf trees, for example, that haven't yet moved northwards and take longer time. Also because we have this big problem with plant browsing on especially more or less all tree species except spruce. And then also that the migration may not go in the same pace for different species when one maybe is dependent on the other. Also, many other cases not old trees all the times. I think researchers have started to see examples of that now. And in the alpine area, we know that 1 degree means that is the climate of about 140 meters altitude. So 1 degree warmer, then you have gone down 140 meters. And since we have had already a 1 degree warming of the climate compared to the climate of 1960 to 1990, already now, it's already so that the vegetation, the biotope zones in the alpine area should have moved upwards 140 meters. And of course, it takes a long time for the trees, especially in that area where it takes that long time to grow old. Takes a long time for the trees to come. But the insects and birds, and they can move much faster and maybe face competition from more southern species then. Also, we see that in large regions we will have these drier summers. Here is predicted change in water balance for Sweden for the different seasons. And as you can see, the predicted change for summer, and this is based on where the predicted model predictions of precipitation has been corrected with real rainfall. So I know that the model predicted rainfall in Sweden is higher than what is measured. So and then we get this result about, so you can see the summers that they get is little change or drier in all the country, whereas the winters are wetter in all the country. So the total rainfall precipitation will increase with climate change, is predicted, and has already done so. But summers will still be drier because the higher evapotranspiration. So that means that for many moist dependent species that are dependent on that it doesn't dry out completely in the summer, that some moisture is preserved through the summer. In many biotopes, and they will face a change over time, and it will maybe problems. So what then can be done in our biodiversity protection work to counteract to some degree some of these changes? To start with, to improve the possibilities for northwards migration of distribution zones. It's very important with the general work for biodiversity protection that is now called to improve the green infrastructure, which is the network of the rare biotopes and substrates such as dead wood and other, to increase the frequency of that in the forest landscape. So to continue to work on that and simply have this reason has added to the importance of that work, has added weight. And basically it's to continue to work for a sustainable forest management of the landscape, where we have a network of completely set off areas, adapted forest management in some areas, and in the rest of the forest managed areas also high considerations to preserve dead wood and to preserve old trees and wet moist areas and such. And a good example of this adapted forestry could be to increase the use of continuous cover forestry in moist areas. And then to improve the possibilities for species to actually stay and persist, because even though we have this climate change, is to increase the focus on protection of places with a moister and or cooler climate, and also with an even temperature over the year, such as shadowed places, north-facing cliffs, north-facing depressions in the landscape, such as in the pictures as examples. And then also to put some extra focus on better protection of moist sites, and to protect the moist dependent species. And that means larger protection zones along streams, along wetland areas, around wetlands, small wetlands, small marshes, and cliffs, as we said, natural springs, and other. And continuous cover forestry at sites with moist soils to a higher degree than today. Also then this re-wetting of drained forest soils on peatland is also, it's not only good for climate in many cases, as Raisa will talk more about, it's also an action to protect biodiversity against these drier summers. And it's a question of what will happen with such re-wetted sites in the long term. Will we continue to manage them with some kind of continuous cover forestry, or will most of them be protected land? It's an open question that I think we will talk, and I think you have been doing more thinking on that in Finland. So I'm interested in that discussion. So I just will tell you about re-wetting, the re-wetting activity that has just started. The government has put 77 million euro in a fund, or not in a fund. They have distributed this over 3 years with the biggest sum the first year now, which is a problem, and then almost as big. So it's 35 million euro this year, 32 million euro next year, and about 100 million, 10 million euro, 23. So that we are now working strongly to develop such on most of the money has been given to the nature protection to the Swedish Environmental Protection Agency, but we think we will get also a large part of the money to the Swedish Forest Agency to distribute to forest owners some payment for long-term payment for that we are allowed to re-wet their drained land and put plugs in the ditches, at enough many plugs to bring about a re-wetting of the area. And we have some inventories made over southern Sweden, because the highest climate, the highest gain for the climate per hectare is on the more fertile the peat is, and the further south, as it seems from research and reviews. So we have maps over where we have the peat in the landscape, and we also have maps of what was agriculture land in 50s and 60s, 1950s to 60s and 70s, and which are no longer agriculture land, which have been transferred to forest then. And if we combine these maps, we can find interesting areas. We also have new maps with which have mapped the ditches with some technique, machine learning technique, because so I think it's laser maps that has been they have been analyzed by computers, you can say. So the ditches that we have on, for example, orienteering maps, as you see an example here, we don't have them on the common forest maps, but on these with these techniques, we can find them. And we can also then call landowners and ask them if they are interested in this re-wetting and if it is a fertile enough peat. Yeah, and we are working with technologies to build these plugs in the ditches, and I've been participating in these pilot projects, and it's been a lot of fun. And we have cooperated with the forest owners in this work. So that was the last thing I wanted to say, but really my the conclusions or my message when it concerns forest biodiversity protection in a changing climate is summarized on this page. So it's more important with the green infrastructure development to have this higher frequency of biotopes and substrates in the forest landscape. It's improved focus, strengthened focus on protection of places with a moister, cooler climate. And it is better protection of moist sites of all kinds, and also recreation of the moist sites. Yeah, thank you.
Okay, thank you very much on your very interesting lecture. And now it is Raisa's turn to set some questions to you and some comments, and also the attendees can make some questions, but please do them to the chat and then press a button to all panelists and attendees. Okay, Raisa, are you ready?
Yes, thank you, Hille, for nice and informative presentation. It's always good to see what is happening in Sweden, because it's quite different from Finland, I would say, but some similarities, of course, we can find and copy and follow and improve our management practices according to your experiences. But first, I want to a bit discuss about biodiversity. You discussed about effects of climate change on migrating birds, and this is obvious observation that the phenologies change. They migrate earlier. But what are the major changes at species level? Do you see new species, invading species in Sweden, or are there some great declines, as we have seen in Finland, great decline in willow tit, which is a small tit occupying mixed stands and needs deciduous trees, decaying deciduous trees, for instance. But do you have similar examples that you see some forest inhabiting species declining rapidly now?
That is beyond. I don't think I haven't heard about any examples of strongly declining forest species, but we have many examples, of course, of coming species. And from my horizon, I merely hear about the species that create problems for forestry. So we have over the last decades, some 20-30 new forest damaging insects have arrived. Some of them probably due to climate change, and some of them due to increased trade with forest biomass. Yeah, but I think there are also many examples of more southern species coming in, and also expanding. Very rare species in the very south of Sweden are now expanding northwards, which can be seen as they are not as threatened.
Yeah.
But maybe you know more actually about if you know examples in Sweden of. I know there are a range of species listed in the red list, listed as threatened by climate. Not so many. I would have thought it could be more because of these complex that I talked about, the problems with the host species and migrating in a different pace, or pushed northwards, you could say, in a different pace than the. So I think with time we will see more and more species listed as threatened by climate change. What do you think so?
I think in our red listed species, we can see those who are affected by forestry, but it's quite difficult to get evidence that some decline is due to climate change. Certainly, it's a factor which is behind decline for some species, but still in our landscape, when it comes to forests, management has so strong influence on everything. So it's difficult to separate effect of climate change from overall influence of forestry. But if we follow something what happens in conservation area, there is management effect is not there, then we might draw some conclusions. But then you mentioned this increasing number of invading insects who might be harmful to forests. Is that linked to drought and climate change? Do you see that your forests are more vulnerable to new insect outbreaks due to drought seasons? And have you already had serious dry period where you see forest decline somewhere in Sweden?
I haven't actually heard about any new insect that seem to have hit harder because of the drier climate. But we had this dry summer of 2018. It was very dry in Sweden. I think Finland too, right? Yeah.
Yes.
And we have extreme outbreaks of spruce beetle now. Yeah. And that is the first time that we get this really large-scale outbreaks only due to drought, not having this storm felling first, which creates a lot of good food. So that is new. And also peat soils have been affected to a high degree. And that is probably because they also get very dry in a dry summer, because they have a low hydraulic conductivity of water, and they dry out really. Dry peat is really dry, and they don't have deep root systems because of normally high water table. So they have. So that is also an interesting factor when we talk about what to do with peat soils in the coming.
So this is interesting, since so far in Finland we haven't really we have lots of trained peatlands, and even in those cases we have not seen any drought effect on growth of trees, and maybe we haven't seen such extremes as you have seen in southern Sweden. But that is something what we should follow, because it's evident that there is a risk. Actually, my last question is related to revetting of trained forested peatlands. You emphasize that you have quite significant funding for that. and focus is on fertile peat. And I'm curious to know, what are the criteria, what you said, how you choose those sites which might be revetted, where a forest owner can get support for that activity? Do you already have those criteria, or are you developing
more
those?
or less, and we we rely quite a lot on the Finnish research for these conclusions, as you have done so much more than in Sweden, but also, but I should say, on the very fertile soils in southern Sweden, as Sweden go further south than Finland, we have more of the temperate forest zone. And so for those results, we rely on Swedish research, but also other countries further south and western, and also very south of Finland. It seems to be in line with the Finnish results.
In Finland, we see that the fertile trained peatlands, they are emission source. There is a high greenhouse gas emissions from trained fertile peatlands soils, and in extreme case, when you have the most fertile sites, then there is the issue is about biodiversity. We have already lost most of those peatlands, which we call letto or korpi. Anyhow, most fertile open peatlands, they are converted to agricultural soils long time ago, and we have hardly any of those left. And any restoration, revetting of that kind of peatlands would be really valuable contribution. And then we have large areas of spruce dominated, relatively fertile peatlands, and they are high emission sources. And of course, the biodiversity loss is also there. And we don't have any program where we would support the conversion or revetting. Actually, at the moment in Finland, we have subsidies to maintain the ditch network. So further training natural peatlands, it's avoided. But if we have trained peatlands, the maintenance of the ditch network is subsidized. And I hope that this will change in 2 years. But situation now is really dark in comparison to yours.
No, we have had a strong discussion also in Sweden, because we had a work. It was a cooperation between us and the sector, forest sector, mainly the forestry then, on how to increase production. And then they wanted to include, or they did in the end, include also ditch maintenance.
But it's not the profitable way to increase production. According to Finnish studies, we already know that if you want to improve productivity and profitability of the forests, then ash fertilization as such is as efficient method to increase timber production as ditch network maintenance. And on the other hand, we have evaluated economic profitability of the continuous cover forestry versus rotation-based forestry on those spruce-dominated peatlands. And in those cases, continuous cover forestry is more profitable than rotation-based forestry, in case that you don't have subsidies there. But when there is always some subsidies which are focused on tending of the sapling phase, and some management activities what you have with rotation-based forestry, they are subsidized, and you won't get any subsidies to continuous cover forestry.
Okay.
So that might still encourage forest owners to go for rotation-based forestry.
Yes, I'm very interested in those references.
Yeah. Anyhow,
Thank you.
this profitability study comes from Artti Juutinen and it's published just now. So it's a really recent paper.
Thank you.
Yeah, these were my 3 kind of questions. Thank you for your presentation.
And thank you for both of you for interesting discourse. And then, okay, that's me again. And now we can start the open discussion. First, I want to also make a appointment at can I say I noticed that the troubles and also good things are quite similar in Sweden and Finland, and also that is also in the discourse of between, for example, forest industry and nature conservationists. So opinions are quite similar also in that, and also the troubles of climate change and also the questions of mitigation is very much similar. That we are quite near, and maybe we have a lot to give to each other if we can open more this discourse. Okay, in chat there is few questions. Maybe it's better I read them first. Okay, there is Dimitris. I believe he's from Sweden. How can conventional forestry practices in Sweden be adjusted in order to increase or minimize the impact of biodiversity? What are companies or forest owners doing on that, and how much more expensive would the harvesting be on continuous cover forest? You can see that so yourself in chat.
It's quite a big question, of course. How can conventional yes, that's that's a very big question with a long answer, but it's in so many ways. Then we have all these demands that are written in the Swedish forest law. Some of them are stronger and some are a bit more like recommendations, or that there is a choice. What we expect from the forestry is that they should, when they harvest, when they clear cut harvest especially, they should look at the area and see what is the most valuable features for biodiversity here, and then take extra considerations to those features, whether it's dead wood or wet sites that could be preserved, or like I said, moist special sites like cliffs or depressions. So they should know about what is most valuable in that area to add to this green infrastructure in the landscape. So there is a cooperation between authorities and forestry concerning this green infrastructure development also. Also, we have this certification. More than half all big companies are certified against FSC, and many private small-scale owners also, and they have also their own certification, PEFC. I think it's a too big question for this. So we'll see what was the end of the how much more expensive would the harvesting be on continuous cover forestry? Yeah, it's continuous cover forestry will be more work intensive over the rotation period. In average, we count that rotation clear cut forestry will be more productive mainly because of the soil site preparation, soil scarification that increases the productivity over many decades ahead. And also the use of plants which have been what do you say, breeding, development, plant tree breeding, is that the word? Yeah, effect, so that there is the new plants produced in the plant that you buy for plantation, they grow better than the trees that the natural genetic. But still they have some genetic variation because that is written in the law. So there is a tree breeding effect, but that could be used also in continuous cover forestry. That you could plant in continuous cover forestry, and you could even do some site preparation, but it will be more work intensive. You are there and thin the forest maybe every 20 years instead of 2 times over a rotation period, and then clear cut 1 or 2 times thinning. So that means more work intensive, and then also, so I cannot give you a figure of how much more expensive, but it's not twice as expensive. No. Okay, maybe that is enough on that, but you have to check that with specialists on that. Ask that question further.
Okay, then Tiina Piron is asking that you were mentioning harmful insects brought by biomass trade. How common is that?
Oh, how common. I don't know if you have heard about this. The pine nematode is a really bad insect that has come from, first it came from North America to I think East Asia, and then it has come also to Europe, and it created a lot of damage in East Asia. In North America, it's part of the ecosystem, so it had its enemies. So the trees had defense, but then it has come to Europe, to Portugal, and it has expanded into Spain, and I think maybe also France, at least Spain, and it's really creating big damage. And it needs very long, warm summers to be able to thrive. But since climate change may bring about these summers in some decades, it's a big danger. And in Europe, we have tried to create rules to minimize the risk with that biomass used for example, for wood for transporting things, these wood plates that you have beneath. They should be treated with heat to kill all insects in them. But still, even with those rules that we have in Europe to try and avoid, it has been found in loads from in ships from Southern Europe. When I heard it many years ago, it was 12 times in Swedish harbors, this pine nematode. So we have, it is a high risk, but still we have too cold climate for it to thrive. But with a change in climate, it's a big threat. So we need to improve those defense systems somehow. Oh, maybe that.
Yes. Urpo Taskinen is advertising a new film about Swedish forestry called More of Everything.
Yeah.
Have you seen that?
Yes, I have seen it. I actually, speaking freely, not as a maybe official, speaking of my own opinion, I should say, I find the messages concerning biodiversity quite correct to a large extent, at least. I've only seen half the film. I saw about the climate issues and the biodiversity issues, and then I didn't see the end because of time limitations. But concerning climate issues, I don't agree with the messages of the film. I think they are. I think they don't look at how societies, the need of material that we have in societies. Of course, we can try and transform our societies to have a lower need of materials, to build less houses. But now we use so much oil for plastics, and we use so much concrete for building houses with a much worse long-term climate footprint than wood, for sure. And when we do use wood for building houses, we can only use as much as around 20% of the tree for that, and then the rest can be used for other things, and we can, for example, replacing products where we use oil, like plastics, and also the rest, about half of the tree will become energy, rest products that can be used for energy purposes, like the bark and the small pieces. And also the rest products that come back from society when we have circulated the fibers as many times as it is reasonable or possible, we can burn the rest. So a large part of the biofuels is really rest products from using this wood for building, and that is definitely much better than using concrete. So the message they try to get out, that bioenergy is as bad as fossil fuels, is definitely not correct. And I hope many of you understand that by heart, or by using your basic logic. People have been using wood for energy for as long as we have been able to use fire.
Yes, it's very easy to see the rest of the film by this link which Urpo has left here. I just saw also half of the film just in the morning, and it was really interesting, but it was also nearby exhausting, because it was really a rough story about the attitudes and the discourse and policies in Sweden, but I say and promise that it is also just similar in Finland, nearby in everything.
And you should know also that most of the researchers that say things in the film, they don't agree to all messages brought forward. Many of those researchers are very well established and have good reputation, but they yeah, they don't agree, and it's said also in the end of the film. I've heard that. So if you look at the film carefully, you can see that some of these more biased opinions that are brought forward when it comes to climate, in my, it's only a few voices that, yeah, put it that way, and those individuals, in my opinion, they don't have the full picture. I think they are probably sincere with their opinions, but they don't look at the full picture.
Yeah, but it's really good to start a discussion on these things, and that's always a really good thing. And now we can stop this lecture, or was it there some new questions? There is Urpo's comment. It is not a question about building less houses. The most of the forests are used for short-timed and not circular use. We have an overconsumption in our societies. Do you want
to? We have an overconsumption, yes, but the trees are grown and harvested mainly for producing lumber for houses and other lumber, and then the rest is of the trees. And also, I mean, the thinnings are made to produce big lumber, because if we don't thin the forest, we don't get the bigger trees, and to produce good lumber for building things. So that even though, yeah, if you want people to stop using paper and overusing and packaging material, which we really do use a bit too much, I think also, then it's not the thing you, the first action is not to stop forestry, because that doesn't change things. You have to work with consumption patterns, especially on, I think, on packaging then, because, yeah, it's concerning hygienic material, for example, it's difficult to, and also we use far too much plastics in the hygienic tissues today. We should change a lot of that to first to wood.
Okay, there was also Dimitris saying, I agree with Hillevi's opinion on the film. The substitution effect wasn't accounted for at all. But also Urpo says that the scientists were well known in Sweden. And there is one question from Tiina Piiroinen. Hillevi also mentioned harmful insects brought by this is already asked. Okay. I believe that is now it's time to change the lecturer, but first we will have 2 minutes cut, and I close the first lesson, and after 2 minutes we will start next. Thank you, Hillevi.
Thank you all, and good question, good discussion. Thank you, and good commenting.
Yes.
Yeah.
Thank you.
Comment next. Okay, let's start again. And next is Raisa Mäkipää. And okay, first I have forgotten to say who I am. And I'm Vesa Luhta, and this is coming directly from very north of Finland, from Ivalo. And then Raisa, you can also tell who you are and just go on, please. Are you ready?
Okay, yes. Can you hear me, and can you even see my slides?
Yeah, we can see that many times. Okay, now it is living not so quickly. Okay, please.
Okay, so my name is Raisa Mäkipää, and I'm research professor at Natural Resources Institute, Finland, and I'm based in Helsinki, so other edge of the Finland. Let's say it in this way. So thank you for invitation to this seminar, and I will talk about climate change mitigation potential of land use sector and management of peatlands, forests, and thank you for Hillevi for starting this discussion about peatland forests already in your presentation. I will continue from that. Natural Resources Institute in brief, I would like to show you this brief concise information, but I emphasize that climate smart carbon cycle is one of the focus area major themes what we are studying at the moment according to our new strategy. So climate issues and carbon smart management practices are really emphasized in our current strategy. But I promised to talk about climate change mitigation and land use, role of land use in there. I will start from this figure, which has been shown many times. It's compiled by Global Carbon Project, and they update information every year. So if you want to find compiled information about global carbon cycles and greenhouse gas balances and so on, you can go to Global Carbon Project, and they provide updated information every year. But this figure overall, it sums up what is the global emissions and how they are divided to fossil fuel emissions and emissions from land use sector, and then these are the emission parts. And on the right hand side there are carbon sinks, and only 44% of the produced or emitted CO2 remain in atmosphere. There are carbon sinks both in forests and in oceans, and role of forests and other terrestrial ecosystems is really large. About 1/3 of the emitted CO2 is sequestrated to forests, and they have had that role for a long time. In this figure, it's illustrated that these are the emissions from all different sources, and globally altogether they could have increased atmospheric CO2 concentration up to 550 part per million. But due to these two players, carbon sinks of forests and carbon sinks of oceans, current atmospheric CO2 concentration is 400 parts per million, which is of course much higher than it used to be before this industrial era, but anyhow, the role of carbon sinks have been large and will be large, hopefully also in the future. So knowing this importance, EU has included forest carbon sinks to climate targets. Currently, they compensate about 10% of the total greenhouse gas emissions in Europe. So if you remember from previous slide, it's their role globally was 30%, and in Europe the sink compensate 10% of the total emissions. And the role of carbon sinks it's already acknowledged by countries and international negotiations. Developing countries has included the forest carbon sinks or sinks of whole land use sector in the nationally determined contributions, which is part of the Paris Agreement. Every country who has ratified Paris Agreement, they submit their plans how they are aiming to decrease emissions or increase their sinks, and sinks are included in many of those reports. And things are, this is just to say that things are also reported in greenhouse gas inventory. So there is already a monitoring system for this, and it's improving all the time, and accuracy of the inventory systems have to be improved all the time. Then I come to Finland, and this is the trends in emissions and removals of the whole land use sector. And negative values are carbon sinks and positive values are sources. And this is only now land use sectors. In addition to this, what I'm showing here, we have emissions from emission sectors, and in Finland they are altogether 52 point something million tons of CO2 equivalents. But here I'm showing what happens in land use sector. There is this part is sinks, and there is a large annual variation of the sinks, which is due to variation in harvest. More we harvest, less we have sinks. And then we have also harvested wood products. They are sink on average, but relatively small in comparison to forest sink. And in land use sector, we have also sources. So croplands are emission sources. If we have a closer look on soil, what happens in soil, we have this is the whole land area in Finland, which is 24.6 million hectares, divided to forest land, which is this largest part, forest land on mineral soils, and then about 1/4 is forest land on organic soil, on peat soil, and then this fraction is croplands. Most of the croplands are on mineral soil, but then we have a small fragment of croplands on peat soil. And highest emissions what we have in land use sector, they come from croplands on peat soil, but also from forests on peat soil we have high emissions from the soil. Trees are carbon sinks also in this piece of the land. So as a whole they are carbon sinks, but soil is decomposing peat is producing high emissions in there. Then I come to forest drainage intensity in Finland. This is quite a word record. We really have high proportion of the peatlands drained, and as I told already during the discussion, maintenance of the ditch network is subsidized at the moment, hopefully there will be change in that funding source, and these subsidies won't be available in the future. But at the moment, landowners they get subsidies when they maintain ditches of the forested peatlands. And what influences this huge drainage effort has produced, sorry, now this slide is in Finnish. I didn't have time to fully translate that, but this is saying that more than half of the peatland types are treated in Finland, and these are different peatlands types. And the first one is spruce-dominated, relatively fertile peatlands, and so on. And message from this slide is that many peatland types are treated, and we don't see that these certain type of peatlands, korvet, neva- ja lettokorvet, and lehdot. Sorry, I don't have English translation now. We don't have any nice view and plans how to protect them. We are losing them totally. So effects of drainage on biodiversity and peatland types, it's really harmful and confirmed many times. Then we already know that drained peatlands are also high emission sources, and that holds for most fertile peatlands. So don't worry about details. I don't expect that any one of you will read all this information, but there are scientific publications, and this is not the only one, saying that especially most fertile peatlands are emission source, or peat soil in there is the emission source, and that's because the peat is so fertile that in aerobic conditions it's decomposing fast. In poor, less fertile peatlands, peat is too quality of the peat is different, and it's not decomposing that fast. So that's the reason why the signal is opposite. But anyhow, fertile peatlands should be in focus when we try to find climate smart management practices. Then we have analyzed where we have those peatlands which are currently emission hotspots, and we have integrated modeling and stand level data, and this is example for northern Karelia, from where we had all more than 100,000 peatland parcels in our database, and we calculated with the SPAFU model the hydrology of the site, and integrated emission estimates which predict emissions as the function of the soil water table, and compiling all this information, we got the map where we have all these parcels which are owned by Metsähallitus, or they are ruling them. And now we have calculated whether they are emission sources or carbon sinks. And because government owns most or less fertile sites in this region, we actually see quite few emission hotspots here. They are shown in red color, and now the Metsähallitus know the locations where they should reconsider their management practices if they want to decrease emissions from peat soil So we have located these emission hotspots with this methodology, combining field data, hydrology model, and emission models. This is a bit more about this hydrology model. With such model, we are able to say what is relationship between tree basal area, which is here in x-axis, and soil water table, and we are saying that by thinning regime and by continuous cover forestry, we can maintain the basal area at the level where we have soil water table at favorable level, and favorable for growth of trees and for greenhouse gas emissions would be to keep water table at approximately 30 centimeters. So from these small figures, we know that by management activities, it's feasible to control water table, and we don't need further ditching or maintenance of the ditch network in there. So this is published paper, and you can read more details and understand whole story by reading that. I will continue to next slide. This illustrates the concept of continuous cover forestry, what we are now testing in our experimental sites. We say that it may reduce emissions from peat soil, and how is the situation in rotation-based forestry? We have water table there, and when we have full stocked mature stand, something almost 100 years or so, and ditches, we have water table which is really very, very low, and this illustrates the situation there. And if we go for clear cutting, it means that water table will be elevated, but then we need ditches, and by ditches it's decreased, and in conditions when water table is very low, we have high CO2 emissions, and when it's almost up to the surface, it means that we have methane emissions, and this illustrates what happens to CO2 emissions and methane emissions. And so meaning that deeper the water table, higher the CO2 emissions, and if the water table is deeper than 30 centimeters, we won't see any remarkable methane emission. This is to illustrate that, and this is experimental data showing this relationship between methane emissions. And what we do with continuous cover forestry, we try to maintain water table at favorable levels, so not too deep for high CO2 emissions and not too high for methane emissions. We try to keep that in about 30 centimeters, and that's possible with a certain amount of trees, which was illustrated here in previous slide. So this is just to illustrate some spruce dominated sites where we are testing this method, continuous cover forestry. And here is kind of repetition what I already explained with the previous slide, how water table affect exchange of different greenhouse gases. I will continue to next slide. So we know that carbon dioxide, methane, and N2O fluxes from peatland forest, they are affected by by water table, as I explained, and they are also affected by site fertility. And now here the gray bar is fertile site, and white one is the least fertile peatland sites. And here we can sum up that soil is emission source when we have fertile soil. On least fertile sites there is a small stink of greenhouse gases, especially methane is sequestrated here. And as the whole, if you take into consideration also trees, these sites which are here in this figure, they are not open clear-cut areas, but they are mature stands, and they're in those cases trees are carbon sinks. And as a whole, these sites are carbon sinks, but still we spot our eyes to these emissions from soil, because here situation represent mature forest, and after clear cutting, this carbon sink of trees is gone, and we have only these emissions left. Then the next slide is saying that continuous cover forestry is more profitable than rotation forestry on trained peatland forest. This is I have two slides here, two figures to illustrate that. This is mean annual increment. A yellow line represents the level what we have in rotation forestry, and here we have different cases for intensity and an interval of the thinnings, and the first column is for thinning, where remaining amount of trees after thinning is very low. It's only 4 square meters per hectare, and the last one is post-harvest basal area is 16 square meters per hectare. And then the first set of cases, it's with the harvesting interval of 10 years, and the second one is with harvesting interval of 15 years. And here we can see that if we have these cases where remaining amount of remaining trees is higher than 8 square meters per hectare, basal area higher than 8 square meters per hectare, mean annual increment is larger than in rotation-based forestry on average. And this illustrates also what is the optimal harvesting interval and post-harvest basal area in this continuous cover forestry. So we find an optimal case where we recommend that harvesting interval could be every 15 years, and basal post-harvest basal area what you leave to the site should be 10 square meters. But also differences between these options, they are not too large, which is good news for forest owners. It's not so critical that he follow strictly this rule. It can be also 12 square meters or 8, doesn't really change too much. And harvesting interval, it doesn't have to be 15. If he decide to extend that to some years, it doesn't make big change. So anyhow, this is profitable to forest owners. At the moment, we have quite many sites where we have ongoing experiments where we test continuous cover forestry in terms of greenhouse gas emissions and growth of trees and water nutrient leakage to the water loading and so on. We have quite intensive measurements in some of our sites, and we hope to have more results in coming 2 years from these projects. So thank you.
Good. We have quite enough time also for comments and discussion later. But first, Hillevi, are you ready there?
Yes, yes.
Please.
Yeah. First, I will just add that I have a background as I have a forester's education, and I have a background as a soil scientist. So I took my PhD in forest soil science. Just adding, so that as background to why I put some of my questions also. Yeah, thank you very much, Raisa, for a very interesting and really dense speak. A lot of information, and it's so interesting for me because we are not only working on this practical rewetting, but we have also, me and a colleague have been working on a review on the climate impact of both continuous use of drain maintenance and rotation forestry, and on one side, and rewetting on the other side. So we have been really looking through all this literature, at least not all, but a lot, I should say. So you will see. But I will start with the background. I think you had a very good, interesting background, and very many pedagogic figures that I will steal to my future, or I will look up this global carbon project that I know is a very good source of information. Yes. I start with a question on the background. You show the carbon budget for Finnish forests, and you said this in a sentence that the less we harvest, the higher the sink. So then when your students ask you the obvious question, then why don't we harvest much less for the sake of climate? What is your answer?
My answer is that harvesting is not due to climate policy. It's due to needs of the human society, needs for the timber resources and all the items what we are gaining. If the only purpose for forest management would be the climate change mitigation, then the case would be different. But the purpose of the forest management and forestry is not climate change mitigation.
Okay.
And then I think that this first one have to understand that it's we have not designed forest management, and we shouldn't do anything. If the only target would be climate change mitigation, then the answer is do nothing, and that would solve the problem. Some restoration and rewetting you could do, but then do nothing. But forestry and forest management we do for some other reasons, and now we are looking for compromise where we can continue with the use of forest resources and decrease negative environmental effects as much as possible. So that's this kind of looking for compromise.
Okay. You don't mix in the substitution effect in your
substitution. It's a field of research, I would say, where one have to do a lot, and we have experts and scientists who are working on that. But we have also calculated what would be kind of harvested wood products. What we have calculated is not substitution, but if we start from that. Current situation in Finland is such that during the last 10 or 20 years, structure of forest industry has changed to direction, which means that carbon sink of harvested wood products is decreasing and not increasing. So from there, we don't see any solutions. And then if we go for substitution, then I think that routine calculations still need more detailed information about effects, what you substitute, and how much you gain from that. So there is a lot to do. There is some hope, yes, but we have to do more and improve the methodologies and really show where we can gain a lot by substitution, and where it's so little that it doesn't solve the problem. It might be nice to have wood products more here and there, but how much they substitute and what, we need more information and more research on that.
Thank you. Yeah, I agree. And it's also a changing, reality is changing, society is changing so fast, and the alternatives. So it's a moving target.
Yeah.
I've been trying in this investigation also to frame it, and also because the question there is what will happen if we don't have this material from the drained peatland? What is competing? And then the reasoning is that perhaps especially in a future, in some decades, it's not so much other materials as wood from mineral soils, not peatland. Is the main competition.
Yeah, right. Especially in Finland, this growing stock, what we have in Finland, forest resources, 1/4 is now on peatland forests, and annual growth increment, 1/4 of that is on peatland sites. But we have to find a sustainable way to manage them. Now we have ignored all the other issues but timber production, and as I told, even economic sustainability is ignored. So there is only timber production with any costs, and that cannot be continued. So if we see that it's economic sustainable, if it's economically more profitable to convert management practices to those who have less negative environmental impact, we have all reasons to do that quickly. And in our case, we are not just revetting peatlands and leaving them out from production. We try to find a compromise when we can continue timber production in there. And we already calculated what happens to overall timber harvests if we convert all fertile sites in southern Finland at the stage when they come to harvest age or dimensions. If we, instead of clear cutting, if we convert to continuous cover forestry, it means that carbon sink is increased quite a lot, and timber yield is reduced, but not too much. So it's also a good compromise to if you reduce harvests from somewhere, reduce a little bit from peatlands and gain large carbon sink there. But this is not in scientific publications yet. It's in one of the preliminary results are reported in one report, but scientific paper is coming by end of this year, I hope.
Yes, I have one practical question on that actually, because I understand it that this continuous cover forestry, the aim is to keep the water table is around, was it 20-30 centimeters below ground? And then my question is, have you or someone in this looked at the possibility to to use machinery on such on the risk for track formation and the soil stability issue maybe?
Anyhow, harvesting and machinery in peatland forests, it's we have to wait for proper winter period make it.
Mm.
Yeah,
that's
to
because
go for
that in southern Sweden we cannot rely on that anymore. But in Finland you can still.
In northern Finland, yes, but we are having risks and uncertainty in southern Finland, and that's, by the way, the reason why we have increasing growing stock, especially on peatlands, because it's not possible to harvest when it's planned to be harvested. There is no real winter, and it's no go with the heavy machinery. So there might be some development, but anyhow, that's one risk. But it's realized already now. It's not related to this water table. It's already now when we have well-trained peatlands. Still, it's no go during the wet period and without frost.
Okay, I have a final question, but it's a complicated one. I want to know, because you show this table of which type peatland types that are net emitters and which even are estimated to have a certain uptake even though they are drained. The least fertile in northern Finland, and as we assume also in Sweden then, because we are relying on the Finnish results on this. And I have looked into the literature, and it's kind of different methodologies reaching the same result. But still, have you put yourself the question, how can this be possible? Because it was the lack of oxygen that made the peat grow once. How come when we drain those soils, how can it be that the peat is not decomposing, even though maybe at a very slow rate and maybe with a lag phase? How come that we estimate that there is still an increase in the carbon content of the soil?
Yeah. When we discuss about those least fertile sites where nutrient concentrations in peat are very low, and that's reason why they are decomposing slowly. Then it's balanced between this slow decomposition and input of new carbon. And when we have trained them for forestry and maybe done something to improve site productivity, then the tree growth and produced litter is higher than this carbon dioxide release from slowly decomposing peat. So it's disbalanced. So trees, when they grow, even if they grow relatively slow, but anyhow, carbon input from growing trees is higher than emissions, and it's a net exchange what we are showing in those tables.
But do you think
what do you think
will happen in the long run? Because will this peat then remain as some kind of relict in the long run, or will it in the end disappear?
Old peat is decomposing, and new organic matter is accumulating. But when we have clear cutting in there, that might slightly change the figure, because then you don't have this high biomass production of trees, and those measurements and those sites we have quite middle age and older stands in there, not clear cutting areas that much. And of course, in clear cutting area, when it's only slow decomposition, slow peat decomposition is continuing and no input from growing trees, then the balance is different. And for some time, of course, there is a net release of CO2 from that peat. But in situation where we have relatively vigorous, in southern Finland, southern Sweden, you wouldn't see them vigorous, but anyhow, this is a balance between input and output. Yeah.
Okay, thank you. That is an intriguing question. Yeah, and I guess it also connects to the general question of what determines the size of the humus layer in northern Scandinavia in the end? Is it climate? Is it continuous growth until it burns even, or is it a continuous growth until we have the clear-cut phase, or
Yeah, and our forests are that much affected by management, like clear cutting, that really have a large impact. And what we don't understand properly is the effect of clear cutting and this part of the cycle, what happens in different kinds of soils. But from peat soils, from those fertile, we have also measurements from clear cutting areas, and we are starting also new site where we will measure from by continuous measurements, eddy covariance, and automatic chambers. So we are learning more. But anyhow, there is a recent PhD thesis about that clear cutting and continuous cover forestry and unmanaged. What are the emissions of soil in different blocks?
Yeah. Okay, then I have put my major questions, and I have learned a lot about this continuous cover forest thinking and knowledge development, and I will actually try to extend our investigation a bit on that matter now when I have got some sources, and I will thank you for the comprehensive speech you made, and very interesting.
Thank you for mentioning that review. When it's ready, I'm more than happy to read that. So let me know when it's published.
It's only in Swedish. I'm sorry.
I can read Swedish. I can read. Don't worry.
Yeah. Thank you.
Thank you for both of you. It was really interesting discuss, and now it's time for the questions. There was a question of that. Can the peatland in natural form will be better or greater carbon sink than ditched and forested peatland?
Answer is very simple. In long term, unmanaged natural peatlands are carbon sinks. There is a deep peat layer accumulated over 10,000 years. So in long term, there is accumulation of the carbon. And then what is the overall greenhouse gas balance? There might be emissions of methane and N2O, which are stronger greenhouse gases than CO2. Net effect is dependent on peatland type and dynamics of methane and N2O emissions. But in general, if you just make a decision based on climate change mitigation target, then you leave peatlands unmanaged.
And then Urpo Taskinen is asking that if we are commenting that if we understand that the main problems for the life on planet Earth is the decrease of biodiversity and climate change, shouldn't the society's main goal to really include the forests in solving that problem? Do you want to ask?
If I understand correctly the comment or question, I would say that role of forests in climate change mitigation is already acknowledged at very high level. I mean that they are already considered, and there is the climate targets and climate plans and agreements and so on, and forests are in there already. And there are already legally binding commitments how how we should maintain or increase forest carbon sinks. And there are already agreements and commitments how biodiversity should be considered in forests, but there are not that strictly legally binding commitments yet. And I would say that these biodiversity and climate targets should be considered together at the same time, because many solutions, what we can find, there are win-win solutions. What we do to improve forest carbon sequestration or to decrease emissions from peat soil, they might have also positive influence on biodiversity. And if we find measurements or measures which have negative influence on something, we should avoid them until we are confident that we can avoid negative influence, because there are so many things to do where we can find win-win situations for biodiversity and climate change mitigation. Hopefully I understood the comment correctly, so further questions are of course welcome if I misunderstood what you are meaning, Urpo.
Yes, Urpo can make a new question if needed. Then Dimitris is asking, CHP plants will stop using peat extraction by 2030. In these open peatlands, there is often much peat left that will decompose. Is it not better to use peat than let it decompose? What is the best after-use option?
Best after-use option, it depends on topography of the site. In some of the sites are such that you could revet them and initiate development of peatland and peat accumulation again. So if the topography of the site allows, you try to regenerate new peatland or revet that and restore that as a natural wetland or peatland. But some of those sites are such that topography doesn't really allow you to collect enough water enough water for revetting, and then it's afforestation. What is your option there? But never leave open peat without vegetation. Never do that. And I think that at least in Finland, it's compulsory for peat mining companies that they convert those open peat areas to something. So they have to do something, and they have kind of 3 options: revetting to wetlands or peatlands, or afforestation to real forests.
We have still time, 10 minutes, but we have no questions just now. Are you willing to say something more to us? You have time, open speeches.
We can also close the session earlier if everyone is satisfied and learned enough. What I may want to emphasize is and I go back to, when I go back to my presentation, and I mentioned the croplands on peat soil. It's not only forests, but also croplands on peat soils where we see problems. There is a high emissions, and we really need to find sustainable management practices there. And there is linkage between peat mining and these croplands on peat soil, because if we stop all peat mining, it means that we won't get peat for energy production, and we won't get peat for animal beddings to keep them dry, and we won't get peat for growing media which is used in green houses and gardens. We have to find material which replace these, and there are quite promising even small scale companies are producing growth media from ruokohelpi and järviruoko, Phalaris arundinake, and so on. So grass species which grow on peat soil. So if we convert those emission hotspots croplands on peat soil to grass production, which is after composting used as a growth media, we can replace peat, which comes now from peat mining areas. So we have to find solutions for all these problems if we want to avoid greenhouse gas emissions. So this is maybe something what I want to add. Full picture includes also sustainable management of croplands, and peat soil is problem also there.
Okay, and Hillevi sent a message there also for Svangnum, and but there is no more questions. I believe we are going to finish this session, but first I have to thank a lot of both of you, and that Raisa's researches were really interesting, and I believe they are quite new also, and I just hope, as how can I say, researches in just as large scales will be done also in how can I say, drier lands, forest lands, especially when we study the purposes of continuous cover management and also other logging styles, that we can find the very best way to handle the forest, and when we are thinking at the same time biodiversity and other things and climate change. But I believe this is here, and I also thank all the attendees which have been with us. Some of you have been also in all the 4 lectures, and I believe we are going to continue this later, maybe next year, but I hope we can keep an ancient seminar in some very, how can I say, easily located place. But also I have learned that this kind of webinars are quite, how can I say, they are really easy to organize, and also we can think here now also this emissions which are coming from traveling. And in webinars we don't have any kind of this. Okay, very much thanks for everybody, and see you somewhere later.
So thank you, Vesa, for invitation, and enjoy your winter time there. Thank you. Bye.
Yeah, I would like to say thank you also for the invitation.
And these lectures will be also seen in YouTube later, and the attendees here can also, I believe, use this material which have been delayed here from both of you, if they first all of course say where they have taken these because we have to give an honor to those who have made the slides. Okay, now I declare this stopped.
Okay, thank you.